We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning, friends. Today we will see nanotechnology and steel. In semester 4th, 5th, I always talk about the steel in a vicinity of material science as well as in a vicinity of metallurgy and mechanical. But today our aspect is a totally different one. Today we will see steel, especially for a civil engineering purpose. As you know that steel is widely available and used in industries in starting from early 19th century, and at a present day also its total production that is in order to 185 million tons, and this data is only for European country. I'm not talking about rest of the world. So itself it is a very huge amount, and by default it shows it has a very huge application, especially in automobile sector, in mechanical industry, as well as in our construction also. But due to uh, very huge amount of usage, by default still is receiving the funding, and that is good thing. And still maybe use either is in automobile or civil engineering, but whenever we do the research, by default we are able to gain some knowledge, and based on that we can use this concept for in numbers of others application. Among that few we will see. For example, I already mentioned in construction industry by default can benefited from the application of nanotechnology to steel, and some of the promising area under investigation means right now research is going on, as well as few that is also available today, and we will see among that few as a uh, case study. For example, fatigue is a significant issue. Fatigue means one kind of failure that can lead to a structure failure of steel, especially when they are under cyclic loading. For example, in bridges, in towers, cycling loading means you have a continuously load that is apply and then unload. And this cycling loading that is not only due to the weight or something, but that is also due to weather atmosphere also. Suppose in winter, in monsoon, we have a temperature that is totally different as compared to summer. So that is also one kind of cyclic loading, and that also affect the lifespan of any structure. And this can happen at stress is significantly lower than the yield stress. Already in 4th and 5th, I have mentioned, and it is a part of our syllabus, that is what is true strain, true stress yielding. Even though suppose if you don't have a proper understanding or remember, then you can just send me a message. We will once again discuss what is such an aspect. Fatigues, even though this can be happen at a stresses once again significantly lower than the yield stresses of material, and lead to a significant shortening of use of life of structure. Whenever you have a shortening of life of structure, we have a waste of money. Suppose any bridge have a overall lifespan that is 15 years, but due to fatigues or material failure, that bridge suppose get broken with a within a year span of 20 or 30, then ultimately it is a loss of currency. And for that we have a n numbers of factor also. And in it is a aspect of research that why any material have a lifespan that is shorter, or by which way we can enhance the lifespan of material. uh, After just getting the understanding, we will see one of the example also. So current design philosophy entails one or more of three limits measure. Among that, first is design based on a dramatical reduction in a available stresses. So that is the aspect of design. Right now we have a wonderful software also. So by using that software, we can using first we draw the structure and put on simulators, and then onwards we can easily do that. And second, that is shorten the allowed service life, means need for regular inspection. So whenever you have a regular inspection, if you have any small problem, then solve it. So by that way you can enhance the lifespan of structure. But this is a significant impact of life cycle cost of structure and limits the effective use of resources. I already mentioned and give an example of bridge that you can same way apply for all. And it is therefore sustainability as well as a safety issue. It is not only the aspect of currency, but a major issue that is also associated with safety. Whenever we have a failure at that time, by default, safety that become a very serious issue. The stresses rises are responsible for initiating cracks from which fatigues failure result. So ultimately, whenever you have failure, so starting point that is crack, and crack always form near the grain boundaries, and that's why role of nanotechnology that is very crucial. For example, research has shown that addition of copper nanoparticle reduce the surface unevenness of steel, which then limits the number of stresses risers and hence fatigue cracking. So by just adding copper nanoparticle, you can easily enhance the lifespan of steel. Otherwise, this steel have a fatigue means cracking, but by adding you can easily by adding copper nanoparticle you can easily avoid it. Advancement in this technology would lead to increase the safety, less need for monitoring. You not need frequently monitoring, everyday checking, nothing, because we have a proper material adding and we are taking the benefit of it. More efficient material used in construction prone to fatigues issue. For example, one of the issue I have mentioned over here, current research into a refinement of a cementite phase of steel to a nano size has produced a stronger cable. These high strength cables as well as being used in car tire. As you know that in car tire we have both the things, nano additives, then steel and rubber. And this steel ultimately give a wonderful strength to the tire. Same to same steel wire we are using in construction also. This high strength steel cable as well being in use car tire are used in bridge construction as well as in precast concrete. And tensioning and stronger cable material would reduce the cost and period of construction, because as compared to our conventional steel wire, it is highly stronger also, lightweight also. So we have both the advantage. We have a reduction in material also, and ultimately we are getting very high amount strength also, especially in suspension bridge, as cable are run from end to end of a span. So in that case, it is most necessary. It is highly strong, very similar to our carbon nanotubes, as well as their lifespan that must be very very large. And you can increase the lifespan by modifying the grain boundary. I have mentioned how to do that. Sustainability is also enhanced by use of a higher cable strength, as this leads to a more efficient use of material. Now, how to do that, as well as not only this steel cable, we have a number of other bolts and regarding things also associated with it. that is also I have mentioned. In both the cases, heat treatment, that is very crucial, and both the cases that is same to same. So I have put that is over here. High rise structure required a high strength joints, and this in turns lead to the need of high strength bolts. So not only cables, we have requirements of other materials also. We have requirements of other steel based parts also. Among that, one is bolt. The capacity of high strength bolt is realized generally through a quenching and tempering. Quenching means whenever we put this material in a high temperature, then directly you have to put in a oil or water, means you have to suddenly decrease the temperature, and by that way you can easily control the phase, because ultimately this phase and phase boundary resulting into crack, means ultimately fattings and material failure. So both the thing contain quenching and tempering ultimately control the microstructure of products, and this microstructure of such product consists of tempered martensite, austenite, martensite. They are the phase, and that you can generate by quenching and tempering. Means ultimately there is a one kind of heat treatment which is we are using in ceramic industry. We are also using this during the synthesis of nanoparticles, sol gel, impulses, deposition, everywhere. But in each material, in each case, punching and tempering, that is a different one. You have to study that. You have to then onwards take a results, and based on that you can say that which uh, temperature range that is very suitable, how to do quenching, which temperature, which material. In many cases we use oil, in many cases we use water. Suppose in case of superconductor, we use liquid nitrogen also. So by that way, material to material story get changed, but it is not only trial and error. You have to perform perfect study, and then onwards you are able to conclude that which temperature range that is very suitable. After each experiment, you have to also perform n numbers of characterization technique like as a XRD, SAM, TEM. Based on that, you are able to identify phase. Based after identifying the phase, you have to compare that data with your load carrying capacity, and ultimately then onwards you have to you are able to get conclusion which temperature range that is very suitable for your material. When the tensile strength of tempered martensite steel exceed 1200 megapascal, even a very small amount of hydrogen imbrids. Imbrids means loss of a ductility of material, and material become brittle. But how to do that? The grain boundaries, and steel material may fail during the use. So that is one of the very serious issue. How to control that? How to get the remedies out of that? How to find out the solution? And this phenomena, which is known as delayed fracture, and has hindered the further strength of the steel bolt, and their highest strength has long been limited to somewhere around 1000 to 1200 megapascal. So ultimately you have a limit as means of more than this much of, this is higher limit of load that you are able to sustain, not more than that. So that is a limitation. But suppose if you have a research work, means by adding nanoparticles of vanadium, molybdenum. Suppose if you add that, then they have improved layer fracture problem associated with high strength balls, and this is result of nanoparticle reducing the effect of hydrogen embrandment, and ultimately now you are able to sustain very high amount of load that is far than 1200, that is in order to 1800 to 2000 megapascal. So by that way you can easily use such a nanomaterials. By that way ultimately you are changing the phase and microstructure, ultimately resulting into high strength. So next time we will see other aspect of specially uh, nanomaterial in the field of civil engineering. Thank you very much.